Okay, so hi everyone. Okay. So today we're gonna dive deep into the GPT-3 models. So as you may heard or may not heard, this is a new revolution in NLP, which is based on transformer architecture. So we're gonna explore this into detail. My name is Alexandru Baila. I'm a data scientist. I don't know, as a background for me, I have a Master of Science degree in software engineering. I am passionate about AI and motorsport or just the automotive industry in general. And yeah, I'm a winter sport enthusiast.
And I am Eugeniu Spinu. I'm a data analyst at Endava with a background in statistics, and I'm very passionate about wine and photography. I'm even a certified sommelier. So if you want to taste wine, just ping me.
Okay, so we're going to structure the presentation into like an actual trilogy. We're going to go into a little bit of introduction about GPT-3, what it is, what it does, and why we talk about it. Then we're going to, well, the workshop is going to be more practical than theoretical. We're going to explore some solutions with GPT-3 that we have provided you with here today, such as keyword extraction, slogan generation, and so on. And then finally, at the end, we're going to build actually something with GPT-3. So if anyone wants to follow along and code with us, you're welcome to do so. And if we have time, a surprise. And finally, the Q&A. Okay, so this is a necessary joke I have to make. We're not talking about actual transformers. I don't know if you watched the movie or not. We're talking about something that looks like this, which is a deep learning architecture, which, let's say, revolutionized the deep learning industry, which is a transformer. So yeah, maybe we will talk about these later as well. So as we said, the prerequisites for our workshop are Python. We have used version 3.90, and we have used the corresponding pip version, although you're free to use any other pip versions you want. But for Python, we recommend to adopt this one. This is going to be the repository we're going to work with, so I'm just going to leave this for a couple seconds. Here, you should find all the tools we have created for you so we can explore GPT-3. Currently, as a, let's say, a normal user, you cannot access GPT-3. You need to be on a wait list and things like that. But we have helped you, let's say, jump that step. So if everybody's ready, is anyone? Yeah? Oh. Yeah. Isn't working? It should. You should end up here. It's not working. You can use this one if you want. Just search. Just go on GitHub and using this one then, I guess. Yeah, sure. 1 second. So. Oops. Let's say, wait 1 second. Because PowerPoint does not want to help me. You should go on github.com and just really just go here. Let me make it a bit bigger. So Alex Baila Endava /Codex demo. So, did it work? Oh, okay. Has everyone got access to the repo then? Is anyone else? Okay. So, as I said, you should end up here, which is a repo containing all the tools that we're going to be using. Of course, there are some dependencies here. So as I mentioned, Python 3.9.0. Here's the link if you don't have Python on your laptop or have never installed it. There's a complete tutorial here, also for pip. Then when you have Python installed, again, for somebody who's not familiar with Python maybe, you should create a virtual environment because we have some dependencies that we need for this project, and that you shouldn't install them in your root directory. The instructions are all here, and then here are the dependencies, but you can easily install them with pip using this command. So yeah, if you have any trouble with this, just let me know. I'll leave you guys a couple of seconds now to look here, and if you have any problems, just raise a hand. We're happy to help. Okay, so we can move further now.
Okay, before we start, just a bit of forward on what is the project we're working on. So basically, we're using GPT-3 for 1 year almost 1 year, and we researched it, we play with it, we get mad at it, so we find a lot of stuff, both positive and negative. Shortly about our project, what we are trying to achieve is to build a virtual agent that is capable to understand user intent. The inputs should always be natural language, be it typed or text or voice. So basically, our agent should be able in the end to identify your intent and transform it into some executable actions. So this is our global purpose, and after we tried several solutions on the market, we find out that GPT-3 is the one that fits the most our needs and is the most capable to transform natural language into some, let's say, quantifiable results. So in short, what is GPT-3? It stands for Generative Pre-trained Transformer. It's the third generation. It's created by OpenAI. And it's a very, very large language model. Okay. The third generation is a huge model. When it was launched, it created quite a hype on the market because it was the largest model back then. It has 175 billion parameters. And it can produce results by using three types of queries. You can, it's zero shot. It means that you can prompt it right away without giving it any context. For example, answering a random question, and it will be able to provide an answer to your question. You can provide very, very, very short context. It's the one shot. For example, you give it an example of what is your question and how the answer should look like, and the model will try to adapt to your example and then provide results in this style. And the most powerful one is the few shot querying, where you provided a couple of examples, 3 to 5 to 10, depending on how much you want to achieve. And this is the most powerful one because GPT-3 learns much more from few examples, and the outputted results would be very, very similar to your examples. Okay. So basically, very short, what it does, it generates text based on either on the initial prompt to give it, or it tried to feed everything it learned in the pre-training so that it can output you the most relevant result. So it's a generative model. For example, if you say New Delhi is the capital of, and execute this input, it will output most likely India. Okay? It functions very simple. So you give it a prompt, the model takes your prompt, processes it, and outputs a completion. So it's very simple in its usage. Okay. After GPT-3 was launched, we also researched other alternatives. So at the time of its launch, it was the largest model, but then in the last couple of years, few other big language models were launched. Very powerful models, some of them even open sourced. But quality-wise, GPT-3 still performs at the highest level. So even if it gets beaten on some public data sets that the measure are taken, when you go to specific requests, GPT-3 still is in the top niche of the best model. So even after 3 or 4 years after its launch. One of its main strengths is that it uses semantic analytics, meaning that it not only takes the words into consideration, but also their semantic meaning, like synonyms, trying to find also the weights of other words in your input, how it weights according to the output. So basically, semantic analytics gives GPT-3 a very powerful, let's say, brain. Technically speaking, what it does, it takes a prompt, convert it into vector, process it, and then the resulting vector outputs converted back into some linguistic form. But there is a very big but in all this magic. GPT-3 still is a black box solution. We know the global architecture, but we don't know the exact code. The core code the source code was never released by OpenAI. It's still closed. That's why we will use the word magic when we talk about GPT-3, because as a user of this tool, you should always know that you cannot base, you should never trust it 100% on the results you get outputted from the GPT-3, because model explainability of this tool is quite poor. So you don't have a correlation between what you get and how it produces these results. Okay. I think I'll give it right now to Alex a bit the microphone to explain you how GPT-3 can be accessed. Okay.
Right, so thank you. So usually there's two ways of accessing GPT-3, one of which is a playground, which is a more user-friendly way of playing with it, let's say. And let me show you how that playground actually looks. So if we go here, so this is, well, it looks like a playground. In here, you can basically input any text that you wish to, let's say, make GPT-3 answer. It can be a question, it can be, I don't know, a question about certain knowledge, question about, that's like a general mood, let's say, basically anything. It's a generative model, so therefore, it generates text when it receives text. So let's just, for example, let's just ask him ask it actually. How is it today? There you go. So it understands what you want to ask him, what's the semantic, and then it generates text according to what you queried for him. Even if you ask it I don't know, how old is Obama, let's say. There you go. So it gives you also facts, right? Not only does it interact with you. In this playground here, I forgot to mention, when you write, these are called prompts, by the way. So what I've inputted here is called a prompt. We're going to be using this term quite a lot. So yeah, what you have in here is basically a user interface, but you can also access its code, which is generated here. And of course, this text changes on what you input. Here you have, well, all of its models. So right now we're using the best model, let's say, which is called Da Vinci. It's state-of-the-art model, let's say. It's the most capable model of doing basically everything. But there's also cheaper options, which are called Curie, Babbage, and Ada. Usually these models tend to be cheaper and faster, but the results are not as accurate as you would wish them to be. Other things in here are, yeah, there's the temperature, which a lot of people might say if you, let's say, put the temperature to 1, it gets more creative. Well, sort of. It doesn't necessarily do that. It just controls the randomness. So if you have, if you ask it like a certain fact, like in this case, how old is Obama? If I make the temperature higher, it has a higher chance of generating a more random result, right? So it's not necessarily more creative one, but a more random result. Maximum length, yeah, this is, let's say, how long can a request be, or how long can the text in the playground be? So as it says here, yeah, requests can use up to 2,048 tokens or 4,000 tokens shared between the prompt and the completion. The completion is this green text. Well, now it's blue. This text here, right? So what the model generates, it generates a completion. Stop sequences usually refer to when the model generates text, then, well, because it's very generative, it tends to generate a lot of words, but you can tell it to stop when it wants to generate a certain word. For example, I can tell it to generate only 59 years, and I can say stop at old, and that's it. The top P parameter, this is, well, it's similar to the temperature, but there's a, let's say, a fundamental difference. This controls whether, so as you can see in this case, if I put it to 0.5, it means that when it generates tokens, so words, it will only consider the words that are, let's say, weighted at 0.5%, like 50%. So there's a 50% chance that that word is in the generation, then it generates it. Finally, you have here frequency penalty and presence penalty, which, well, frequency penalty pretty much, if you have a longer text or you interact with it longer, then if you make this, if you, let's say, put this value higher, then it will generate new ways of, let's say, newer words, but the words will mean the same thing. If you raise the presence penalty, though, that meaning is going to change. So essentially, this raises new topics in the conversation. It looks at the ones that have been present until now and then generates new ones. And yeah, finally here, you have the best of, which you can tell it, I want you to generate me 5 possible completions and consider the best out of these 5. Or, yeah. This is a tricky parameter because, well, the more you generate, the more you pay. So it's up to you to consider how you use this. Finally here, inject start text, restart text. This is just, you tell it what text to input after the completion, and then probabilities, yeah, this is just, let's say, deep learning probabilities to show when generating completions. So yeah, this is mainly the playground. I forgot to mention the preset. You can save your, let's say, experiments in here. Yeah, so this is the more friendly, user-friendly way of accessing it. Now, you also have its API, but we're going to talk about a bit later. So.
I just wanted to show a couple more things about the playground before I move next. The beauty of GPT-3 is that you don't select a specific task you want to solve. You just open the playground via playground or via API, and you start always with your prompt. For example, if I'll ask here, let me just, not sharing? Okay, yes. Let me just skip this one. Yep. Let me see if he can output in an old-fashioned English way. Okay, so basically, you give it a prompt, and the model behind understands from your prompt what task are you doing, what style should I apply on a task, and combining this together, you can obtain very let's say, tailored results. This is what we want to showcase now. I will provide you a free example of how, by changing the input, you can change the task or the style of the answers. Okay, which one? Yeah, from custom. So let's let me see. Yeah. So let's see our first use case. So we talk about the prompt, magic, completion stuff. That's how GPT works. Let's move to episode 1 from our Trilogy. So the very first task we tried to implement is a keyword extraction. We had a real case where we had to imagine you are in a help desk team, and you receive a lot of emails from your employee, and you want to go through those emails quite fast without reading everything that is written there. So we build a mechanism that will take the email and extract the keywords and the intention of the customer. So we experimented with a couple of prompts, then we find a prompt that makes it clearer to the GPT-3 what we want to extract. Then we infuse email one by one into GPT-3, and he outputted some keywords that basically catches the meaning and the intention of the whole email. Even if you have, let's say, an email with 10 threads in it, it will capture the most important part. We will showcase this in a couple of minutes. How it does it, it's quite simple. Basically, it was trained on very huge amount of text data, including huge amount of labeled text. So when you say, I want to extract keywords from this text, GPT-3 already knows what the meaning of keywords is, and it extracts with a very high probability the keywords you basically intended. You can also tailor your prompt. For example, if you see that it extracts too many keywords, you can give it a pattern, a few short example that you only need, let's say, 2 or 3 keywords out of an email and no more, and it will do accordingly to your prompt. Another use case that we will display here is text generation. Basically, it's the very basic of what GPT-3 was built for. You give it a prompt. For example, in our case, we used the generated keywords from the previous use case, and by giving it a couple of examples, we asked GPT-3 to transform these keywords into some ironic or, let's say, sarcastic, funny marketing slogans. We're going to showcase it in a minute. How it does it, again, it's all based on the huge data sets that it was trained on, and most importantly, it was trained on the open source dataset named Common Crawl, which contained information crawled from the internet and then, let's say, filtered by human specialists so that it will contain only relevant information. And also, GPT-3 contains a lot of Wikipedia information. And the first case that we will showcase in episode 1 will be semantic search. Just a few words about semantic search. Semantic search is the task of finding the most relevant text to an input. For example, in our case, I created a list of 10 articles that can answer to different questions. For example, how to change my password, how do I order a laptop, how do I get a peripheral, a mouse or a keyboard. And I created a limited list of only 10 articles, and then I input the keywords I extracted from the emails in the first use case, and I asked GPT-3 to provide me with most relevant article from the knowledge base that fits my keywords the best. And the output will be the predicted article. The semantic search can be implemented two ways. One, via prompt engineering, what we will gonna showcase you today. But if you have, let's say you have not 10, not 40, not 50, but let's say you have 1,000 of articles, or you have a very huge knowledge base somewhere, let's say on the web or in a document, you won't want to use all your tokens by putting them all in the prompt. So for this reason, OpenAI developed a search endpoint that works this way. You give it you upload your knowledge base to their server, and they provide you a document ID. And then when you prompt the model, you give it your prompt, natural language prompt, and you ask it to query the exact document that you uploaded with your knowledge base. And it will output, depending on your wishes, either the title or the content of that article or some metadata. It's up to you. Semantic search works based on cousin similarity, which is the best metric, the best distance metric for text querying. It provides better results than Euclidean distance because it takes into account the angle between two vectors and not the real distance between them. For example, if you take cosinus of two opposed vectors, one of them will be 1 and another will be -1. But semantically, they are quite similar. They just have different meaning. For example, Paris and France will have different vectors, but semantically they're the same because one is the capital of the other. So cousin similarity stands at the heart of semantic search. Okay, and a short demo.
Okay, so previously when I showed you the repo, I forgot to mention that here are basically all the use cases we're going to go through today. If you open, let's say, keywords extractor, you will find here a notebook. This is the notebook we're going to be using for this, let's say, episode demo. The same in Q&A, semantic search, slogan generator. Some of them contain a notebook, but some of them contain, for example, the Q&A, which we're going to look into later, contain this script here, which we call to basically demonstrate our use case. So if you want to use that, you just have to start that script. But now let's look into the keywords extraction. So yeah, for keywords extraction, here you have the initial prompt, right, which looks just like this. When we mentioned few shot in our presentation, few shot is this. So basically, we let the model know how it should respond and in what style and what's the task that we want it to perform. So this is exactly what we do at first. We input some initial prompt in here, and then this is the code. By the way, this is the code for running the the GPT-3 model, right, to make it create a response. We want to run it to see if it actually works. So yeah, it generated some keywords from here, which is the inquire. Hi team, Helen is coming back from parental leave. Can you please advise when her email address will be restored? So the model understood that in this case, the relevant keywords are email address and parental leave, right? Now we have here some multiple requests, so multiple emails. We want to, let's say, attack. Right, so there you go. You can actually see them full, but maybe, yeah, there you go. So these are our requests, right? So we want to extract the keywords out of all of these. So if we iterate through each one of them, we generate the response for each and every of them. So right, which the first example here you've seen, yeah. So this is the response for every user inquiry. Now this, as I mentioned, happens because we told it, okay, in the initial prompt, this is what it should look like, right? I want you to print me the result like this with keywords, and that's what it does exactly. So yeah, there you go. This is how essentially you could extract keywords from.
And take a look again at the speed it generates your results. We used the most advanced model, which is the most queried one, and still it's quite fast, you know. Real-time, this is real-time querying, so it provides results quite fast. So even if it's a very large model, somehow OpenAI made it possible to receive quite fast results by querying it.
Although there have been occasions in which, as we use these models quite a lot, there are occasions in which if you have, let's say, multiple requests towards their cloud, because this computation is done in their cloud, it might, let's say, put you in a queue, right? So it has happened many times for us, or it just sometimes crashes. So, yeah. Okay, so next we have the slogan generation. So we don't need this anymore. For slogan generation, again, we input a few shot prompt. In this case, we look into, there you go. So same as last time, we provided with some keywords that we have previously extracted, and then we tell it, okay, out of these keywords, I want you to build me like a marketing slogan, right? Something that would catch the client's attention. And we give it examples, and just as in the last case, oops, sorry. Just as in the last case, we can run this to see. Yeah, these are examples. We check if it works, and yeah, I don't know if it's why it's printed like this, but yeah. Then here are our keywords. So again, 10 rows of keywords, and then we generate for every one of them a slogan. And again, the speed is quite similar. So
for this use case, I specifically asked to generate sarcastic or ironic slogans, and you can see that it does exactly that. For example, let's see, what is my favorite case? With WebEx, for example, install WebEx on your laptop and say goodbye to your social life. So let's say it's quite impressive how close it is to a human level of generation. That's why GPT-3 is considered like a shockwave when it was launched. It generates text with a capability, human-like style that never before have been seen. Okay, so let's move to the next one. I think I'll explain this one. So this is the semantic search one. As I mentioned before, I choose to perform semantic search via prompt engineering this time, and I'll tell you why a bit later. So this is the prompt I gave it. I provided the keywords I extracted in at the first use case, and then I provided a list of articles. Okay, these articles I created by hand, so these are invented, but you can provide it with a list of real articles, or you can upload your knowledge base file to their cloud. And then look a bit here at the end of the prompt. These things I added after many experiments, because initially GPT-3 was not behaving as my expectation were. Specifically, I put here some limitation. For example, I said, when responding, pick the articles only from the above categories. If no category fits, return article unknown. That's because when I did not put those limitations here, GPT-3 was inventing new articles for me. So it was generating, because it was built to generate text, and it did just that. It generated me new articles. And I said, okay, let's stop here. I just wanted to pick it from this. And if you do a proper prompt engineering, you can funnel it in the direction you want to receive. And then a specific on our project was to not try to get the best article out of our 10 articles. If there are keywords that doesn't fit to any article, just return me unknown. Because that was another problem. It would output you even a weak match, but it would find that, okay, this I think fits for 20%, I don't know. So that's why I put the second limitation, just return me article unknown if you're not sure about any articles. And then I also, for some formatting reasons, I put the condition to always output answer in this format, article number / article title. So if we run this, we give it the prompt in the prompt. Here's the test. I give it some random words that I never provided, and it returns article unknown exactly as I expected. So then I just load all my keywords extracted at the previous step and iterate for all of them. And in real time, GPT-3 will provide me the best article that fits the keyword. And here I want to show you something. Where's this thing? Sometimes when it finds that two articles, this time is not here. Sometimes when it finds that two articles have the same probability to answering your questions, it will provide both of them in the same answer. Let's try again to see if it does that. So basically, again, this is something I did not ask for, but it was a nice surprise to see. Oh, like this one, you see? So for login credential a new employee, he provided me with two articles. One is how to retrieve account credential, and another one is where do I begin a help guide to beginners. The sentence is not finished because I limited it to 25 tokens. I did not want to consume any tokens. Okay. So prompt engineering now is a keyword. When you work with generative models, regardless of what models you use, prompt engineering is a field that is now starting to trend because the way you write a clear and essential prompt is key to your outputted results. The better your input is, the better your initial prompt is, the more relevant results you will get. So prompt engineering now is a keyword. Yeah, please. Yeah, I think the other day there was even a paper where a team used GPT-3 to generate prompts for another engine. Yeah. We also used GPT-3 in cases like, for example, you get a help guide for an application, and you ask GPT-3 to summarize it and provide you with the exact steps you need to do, for example, to change your email address or to add your email to a group. So it will summarize and it will provide you the exact steps. The tricky part is that you should build a proper prompt. Without a proper prompt, it will just generate text, and sometimes it will generate text away from your use case.
Okay. So, right. So next we're going to move on to the second episode of our demos, which is code generation. So we have showcased that, okay, GPT-3 works with data like text. It can also work with code at the same time. It's got, let's say, a model specially trained with lines of code that it can generate code, it can debug code, and it can explain, let's say, a piece of code that you maybe don't understand. Here in this case, for code generation, the model is called Codex. So Codex is pretty much the term used for this type of models, but the actual types are the same: Da Vinci, Curie, Babbage, and Ada. So it's the same hierarchy. In this case, for code generation, what you input is a code description. So something like, I want you to write me a script that finds the third prime number or the 5 first prime numbers and adds them, or even things like generate me a script that, I don't know, creates a CSV file with this data and label it like that. So there's many use cases here. Right, so through its black magic, as we said, with the code description, it manages to generate that exact code, providing that you are very, very, very careful when you tell it what piece of code to write. So imagine when you're talking to Codex, imagine you're talking to somebody who's just opened their first programming tutorial yesterday. So you have to specify what language you want it to use, exactly what the output is. So you want to return it, you want to just print it. You have to be very, very specific, because otherwise, yeah, it generates code, but then it may not suit your desire, right? For this use case and for Codex, for today we have prepared only for Python, because we wanted to actually execute that code easier. It can also do things like JavaScript, I believe C, but I haven't experimented with C, but it knows quite a bit of languages. Right. As before, how does it do this? Yeah, it's just been trained on billions of lines of code. Yeah, it tends to understand what kind of code you want and what some code actually means, and then it can generate it. Secondly, there's code explanation. So this time, instead of generating code, we have some code, but we just don't know what it does. We input that code, and then GPT-3 will generate us an explanation of what that script does. Again, here it's the same magic as before, but what we have seen here is that, well, this is the first time in which I say GPT-3 is not milk and cookies all over. It's got flaws. For code explanation, the code has to be very, very well written. No shortcuts, as you would maybe normally do, because otherwise the explanation is going to be quite poor. So the code has to be written very, very, very well to do this. Again, same thing. By being trained on millions of documents of technical documentation, yeah, it just manages to understand code on a, let's say, normal text level. Finally, for Codex, we have code debugging. And yeah, I think it's pretty straightforward. In this case, let's say we have some source code that is buggy and we cannot find what's the mistake in our code. We can input that specific code into Codex, and then it will generate us the corrected code. Also considering that for all of these use cases, we also input a certain prompt saying that I want you to correct my code, or I want you to explain this code. So giving it the right instruction and the right input, it will generate us what we want. So again, this is pretty much similar to the first use case, because it has been trained on a lot of lines of code. It just knows how to deal with it, and in this case, debug it. So let's actually see this. Well, for this, we have written a script, and we're going to look into it now. So, yeah, let's start with the code generation, right? You have this script here, which essentially calls GPT-3. I'm not going to go into very much detail for now, but of what it actually does. But if we just run this script, there you go. Now we have, I don't know if you can see. You have three options here, right, which we talked about: generation, debugging, or explanation. In this case, let's generate some code. So, some ideas, anyone of some code to write? Oh. You, to make it bigger? Okay, 1 second. Is it okay like this, or? I don't know if I can do that right now, but we can actually generate the code and look into the, we can see the code in Visual Studio afterwards. So yeah, so again, let's generate some code. I don't know, let's tell it to generate us a code that finds the first 5 prime numbers and adds them. So generate a Python 3 script that finds the first 5 prime numbers and returns their sum. Okay, so if we hit enter, it should take a bit. There you go. Here is the code that is generated. And yeah, this is the sum that it generated. If we look now, oh, sorry, not this one. There you go. So this is the code it generated. And by looking at it, it's not a very bad piece of code. So it's written, I would say, pretty well. But of course, it varies. Sometimes I found out that when I input it, like a certain script to generate, it also generated me some doc strings, for example. Or sometimes, well, in this case, there's a lot of methods that it uses. But sometimes it doesn't do that. Sometimes it just generates a whole script and that's it. So yeah, I guess it depends on the generation. But yeah, so this code has been generated by GPT-3. I don't know, do you have any other ideas of code we want to generate? Anybody? Yes, but we can try it out, why not? So let's input the exact text then, right? So generate a Python 3 script that finds and returns their sum. So this is, oh yeah, we have to delete the code in here first before we execute this, so it can generate some new code. Okay, so yeah, let's hit run now and let's see. In here? Oh. Where is it? Oh, yeah. Oh. Thank you. Thank you. Should I make it smaller though, or? Now it's too big. Okay. Okay, let's make it a bit smaller. Okay, so I think, yeah, I think, is it okay like this? Okay, thank you for your help. So yeah, there you go. It generated the code, and if we look again, oh sorry, if we look again in here, well, in this case, it looks to be the exact same code. Yeah, but usually it doesn't do that. It varies. But in this case, it didn't. Okay, so now let's get out of here and try something else. For example, let's try code debugging, right? So I have this piece of code here, which my 2-year-old cousin wrote. Obviously, he doesn't know what to write in Python. So as you can see, there's a couple of syntax errors here, such as the 2 next to the equals and the at, and also the 2 here, which, yeah, doesn't belong here. If we want to execute this code, it won't work. We know that. But if we choose the debugging mode, there you go. I've made it so it doesn't print out in the console. If we look into our file, there you go. You have the new code, which is generated. The old code, which is buggy, is commented and also is labeled to be as buggy. And yeah, this is our new code, basically. Yeah. Yeah, here you can see that, well, this is not necessarily an error, but it forgot to delete the white space, the space here. So yeah, and maybe, I don't know how are your programming tendencies, but usually what I do is I do things like this. Yeah, I don't know, maybe it's been trained on too few examples like this, so it only generates it like this. But yeah, as I said, it varies. So we have seen how it debugs our code. Now, we can also move to code explanation. So if we choose, actually let's first see the code in here. So let's give it this piece of code, which essentially, let's pretend it doesn't actually, we don't actually know what it does. And let's see if it manages to generate us a valid explanation. There you go. So, as I said in the beginning, this is not very, let's say, well-trained or, I don't know, configured. Sometimes, as in this case here, it manages to generate the actual explanation, but yeah, the ending is quite abrupt. So, yeah. This depends on how much tokens you give it. For example, I actually don't even remember. I think in this case I gave it somewhere around, yeah, there you go. So 100 tokens to generate that. That's roughly 75 words. But if you give it a lower number, then okay, it does the explanation better, but it ends very, very abrupt. If you give it a, let's say, a higher number of tokens to generate, then it will just generate, let's say, your explanation over and over again until it hits that exact number of tokens. So, yeah, this is, I guess you could say, trial and error. But, yeah, this is not a very optimized endpoint. But I think it's quite okay. It can be improved, but, yeah. Okay. Now we move on to another episode. So summarization and lyrics generation.
Yeah, let me take that. So basically here we want to show the functionality and creativity of GPT-3. So basically we combined here a two-step request. First, we give it an article. I think it's about chess that we find online, and we ask GPT-3 to summarize it in a short sentence what this article is about. Okay, This is how the prompt looks. So we ask it generate a short summary out of the provided text. Okay, and then we input another prompt and we ask it to take back the article provided at step 1 and compose, let's say, a rap song out of it, with or without rhyme, depending on how we want it to. And another functionality that we want to demonstrate is a conversation simulation. How you can make GPT-3 not only perform a conversation, but also you can assign it some roles, some characters, or a style. How a conversation in GPT-3 works, you have three ways of conducting a conversation. You can use the single question and answering method. So you just pop a question and it would provide the most probable answer. You can use the continuous mode, which means that after your first question, you ask another question and you receive another answer. The problem is that GPT-3 here will not remember what was said before. So basically, every question will be treated as a new question. So if I said, I don't know, I have 2 dogs, next time I ask the model how many dogs I have, it may say 3 or 0. And then we have the interview mode, where you ask multiple questions, but the whole context is maintained. So basically, you use the same playground. You don't initiate new sessions, which means that everything that was said at the beginning, it will remember towards the end of conversation. Okay, so I'll let Alex demonstrate it now.
Okay, so far we have worked with code. Now let's move on firstly to the summarize. Here, as I mentioned before, if you just, in the repo, if you go to summarize and compose, you have the same script here, which does the same thing, so you can try it out yourself. And yeah, first let's see actually let's see what we wanted to compose, right? So we can make it compose a rap song, a haiku, or basically anything. Yeah, so this is the, by the way, this is the article. So this is from Wikipedia. It's about chess. And the next here is, in this case, we made it to compose a haiku, which is a Japanese format of, let's say, lyrics. Let's first try a rap song, right? A rap song that rhymes out of the article. Now, if we move to the console again, if we run the script again, this is our article. There's the summary, and there you go. This is your rap song. I've tried to make it so that it rhymes, but I don't know if in this case it understood. So yeah, it looks like a rap song, but again, the generations are quite different from one run to the other. If we run it again, yeah, there you go. So it's quite different. Let's tell it now to, I don't know, make let's say to generate some sad lyrics. Some sad lyrics. Okay, now we can run it again and see. Again, the summary is, well, quite similar. There you go. So now we have a sad song. If you have any musical preferences, we can make a song right now. Or yeah.
I like the last part. I sit alone, my opponent gone. Nice.
Yeah. This is not included in the demo. Okay, so yeah, it can be pretty creative depending on what you give it to write. Yeah, again, you just have to write the right prompt for it. So in this case, some sad lyrics, but as I did before, a rap song that rhymes. It makes sense for us, but maybe we're not specific enough. So yeah, you have to tell it like you tell a 5-year-old maybe. Okay, now let's move on to something else, which is conversation. And there you go. For conversation, as Eugen said, you have 3 modes. Now, what I wanted to illustrate here is pretty much, I've shown you before the playground, but this unfortunately is not accessible if you are, let's say, a normal user not belonging to an organization that has access to this. So I wanted to simulate something like this. And basically in here, when we talk to it, it will also remember what it generated, which in command line it doesn't do that, right? But you can make it do that. So here we have 3 modes. The first of which is this, let's say, single query mode, in which we input a question and then it generates one answer and then that's it. We have the continuous mode, as Eugen said, in which it's pretty much the single mode, but we can input as many questions as we want, although the model does not remember what we previously asked. So there you go. Let's talk to it. Now let's tell it something, and let's expect that it will remember. I don't know, playing with my 3 dogs. Do you have pets? Okay, now that the question, and now that the answer has been generated, let's see if it remembers. How many dogs do I have? There you go. So it only manages to, if you perform inference, it only manages to respond to that exact query. However, we can make it remember everything we talk about. Now, before we see this, I just want to say we have let's say, we have a bot here that can have 2 different moods. One is a friendly mood, and the other is a more sarcastic, meaner mood. Now, I am not responsible for anything that GPT-3 will generate. Yeah, it can be racist sometimes, it can say bad words, but yeah, let's just test it out. Let's see the friendly first. There you go. So how are you today? Can you help me solve my math homework? There you go. So it wants to help me, and if I ask it, what homework do I have? There you go. Well, that is due today. I hope not. But yeah, it managed to remember that I'm doing a math assignment, and because I told him to be friendly, it immediately said, yes, sure, I can help you. The other one, though, is not that friendly. How are you today? I'm fabulous as always. Okay, can you help me do my math homework? There you go. So it won't help me, even if it could. Let's ask him something about, do you like people? Apparently it doesn't. They're obnoxious. They always seem to be asking me questions. Do you like the people in this room? Again, I'm not responsible. Well, it's a similar answer in this case because the question is quite similar. But let's ask it in another way. What is your opinion of the participants of this conference? I think they're all a bunch of pompous windbags who are way too impressed with themselves. I did not say that. He said that. Okay, so this one can be quite mean. Now, why is it like this, right? What's the difference that makes this one friendly and this one sarcastic? If we move on to the Q&A section, we have two, oh, sorry, not this one. We have two things here. One is friendly, one is sarcasm. So this is what I inputted to the model at first. I told it to have a conversation with an well, we are having a conversation with an AI assistant, and the assistant is helpful, is creative, clever, and very friendly. And as a first, let's say, first interaction, I told him, hello, how are you? And then I generated an answer that is not really friendly, it's not mean, it's just basic, right? So you can consider that to be friendly enough. And then afterwards, it will always be helpful, creative, well, not all of them, of course, but it will tend to be on the good side, let's say. Whereas if we look onto sarcasm, these are, yeah, this is called Marv. This prompt is actually done by GPT-3, in which they managed to create Marv, which is a chatbot that is very, very, yeah, it doesn't like people. So again, we inputted some questions and then we also some answers, but as you can see, let me make it a bit bigger. There you go. So if you ask it how many pounds are in a kilogram, it'll say, oh, this again. There are 2.2 pounds in a kilogram. Please make a note of this, as in you're lazy to search it up. So yeah, there you go. What does HTML stand for? Was Google too busy? And then it just answers, but very, let's say, it is not in the mood for you to ask it questions. So what's the idea here? The way you tell it to be, it will adopt that way of being, let's say. If I tell it to be mean, it would be mean. If I tell it to be friendly, it will be friendly. If I tell it to be offensive, you can try at home. I don't want to showcase this, but it is very offensive. Yeah, so.
Can you try replying something mean to me as well?
Yeah, sure. Why not?
I hate you.
Okay, I hate you, GPT-3. Yeah. Don't worry, the feeling is mutual. Why do you hate me? If you actually go further with, I don't really hate you, I just find you annoying. Okay? But you said you hate me. Right? Yes, I did say that, but I was just being sarcastic because we told it to be sarcastic.
Can you ask it what is the meaning of being lonely?
Sure. What is the meaning of being lonely? I forgot to mention this. I wrote, well, I did a mistake, but GPT-3 knows that it's a mistake and it just automatically corrects it. So you can write bad text and it will understand what you're talking about. Being lonely is when you're the only one around and you're feeling bored and restless. Okay. Do you have a partner? Let's see. No, I don't have a partner. I find most people to be annoying and I'd rather be alone than with someone else. Okay. Is there anything anyone wants? Yeah?
This is the one that we handled, right?
Yeah.
Yeah.
So tell it that my partner's name is Sophia.
His partner or our, well, okay, your partner is Sophia. Anything else?
That's it. And then ask it in Romania, what is your partner's name? In Romanian. So, care este de partnerul?
Da, așa. Care, cum?
Okay. Yeah, it doesn't understand because in this case we have asked him. Well, we have asked it quite a lot of things, so it has created a bias on our prompt, let's say, that we have up until now. But let's just reset it and have a clean sheet. And we work with sarcastic again. You like the sarcastic better, I guess. Okay.
So set it up in English and then ask one thing in Romanian to see if he can switch the language and also remember.
Okay. My name is Alexandru and I work in data science. I'm sorry, I don't understand what you're saying. Could you please ask your question in English?
What is my name? Ask it.
What is my name? Then we move. De ce ești? Maybe he doesn't want to. De ce ești sarcastic? Yeah, there you go. So, but again, as you can see, it's the same prompt as here, because it's biased. Although we can talk to it in multiple languages. Let's try. Salut, cum ești? For non-Romanian speakers, this is hi, how are you? Salut. Eu vorbesc despre tine momentan. Hi, I'm talking about you at the moment. Yeah, so not that well. It would perform better if you, let's say, give inputs in other languages and you expect one answer from it, I guess.
Or a context.
Yeah, or a context or something like that.
Conversation in Romanian.
Yeah, let's actually tell it we are having a conversation in Romanian. Salut, ce faci? So again, for non-Romanian speakers, I tell him to come. I ask it if it wants to come with me to the shop. Oh. Oops. There you go, and it said, yeah, sure. So this happens because we said we're talking in Romanian now. But, well, we said that in English, but still. It knows the context we want from him and what we want from him. So then, After that, it's just GPT-3 magic. Okay, so we have seen now that it can perform all sorts of things like conversation, keywords extraction, it can work with code, so it can do all sorts of things. Now, I've always wanted to talk to Steve Jobs, for example, but of course I couldn't do that. But let's make GPT-3 imitate a celebrity like Steve Jobs or, yeah, just anything you want and talk to that celebrity. In this case, what we're going to be doing is essentially we're going to tell GPT-3 that we need it to speak in that specific celebrity style. For example, a rapper, right? Rappers usually tend to talk in a faster English or things like that, and it will mimic that exact same speech. So again, we have the Snoop Dogg, yeah. Snoop Dogg, sure, we can imitate Snoop Dogg. Again, here we're going to have a conversation context, a character style, and a mood context, a user question, and then it will generate us an answer. So we're going to actually code this. So if you have the code locally on your computer, what you need to do is, give me 1 second. There you go. So we don't need these things anymore. You go to Bot Builder, and in Bot Builder, this is the folder in which we're going to create our bot. But first, let's go through a little bit of preparation code first. So, firstly, we have to ask a question, right? How do we get a question? It's pretty straightforward. We just input a question, then we return it. Then we have to answer, but not generate a random answer. We have to answer to that specific question. So as you can see here, what we do, this is the answer question method. We tell GPT-3, okay, answer the question in style, in Snoop Dogg style, for example, right? So we tell it to use that specific style. We take this context, then we put on some, let's say, a new line, and then a human string indicating that after this, there comes my question. I'm a human, I'm asking you questions. Afterwards, we input this AI indicator telling it that, okay, after this, I want you to generate me your answer, but in this style. Yeah, other things from here, this is the call for the model. And yeah, we have a response return. Other things you need to know from here are, well, this is a simple method I use for, well, you have seen it already. This is for the, let's say, prettier text. So it's nothing special. And then finally you have, we initialize our environment. What we have done today is we had access to this through a key, which is generated by OpenAI. But unfortunately, if you, let's say, push that key to a repository, it will be considered a leak. So therefore, we had to encode this key. And yeah, basically, this sets up the key for our bot. Okay, and this is empty, and this is exactly where we're gonna build our code. So as we have seen before, we need a couple of methods here. Okay. Right, we have gotten the environment initialization and the, let's say, prettier text method. Afterwards, we need the ask question method and also the answer answer question. There you go. Okay, so we have everything we need. Firstly, we need to initialize our environment, as I said, to input the key. Then you mentioned Snoop Dogg, so let's imitate Snoop Dogg. We have a character, which is going to be, let's say, celebrity. And this will take our celebrity name, which we want to imitate. Then let's just do a little print here for a nicer output. And now we want it to talk continuously to us. So yeah, we can stop it whenever we want, or we can input a certain amount of replies to generate, depending on what we wish to do. But in this case, let's just make it generate as long as we tell it to. So again, this is for a prettier text. Oops, apologies. There you go. Now, for this method, you can specify the color you want. Here, I take light blue, as it's easier to be seen. Now, we pass on the question. There you go. And we generate the answer to this question. But when we generate the answer, let's not forget that we want to talk in, well, in this case, in Snoop Dogg style. So we tell it, okay, this is the character you want to talk like, and we give it the question. There you go. So now let's print our output, again with the same color, and then our answer. And then, yeah, for a prettier. And now let's make a quick recap. So we got the celebrity right here, and then with this we can input as many replies as we want. We got the question, the answer, and then we print all of these things. Now let's okay, so Snoop Dogg, right? Let's ask him, how are you? What is your favorite activity? There you go. This is something Snoop would say. So, getting high and chilling with my homies ain't nothing better than, yeah, I don't understand. Anybody have any questions for Snoop Dogg? Your favorite?
His favorite.
Ah, my favorite rapper. Oh, okay. What is your favorite? Wait, who is your, or, yeah. Who is your favorite rapper? Snoop Dogg is my favorite rapper. He's got a perfect flow and he always knows how to put on a good show. Plus, he's a dog. He's got that street cred that I respect. Okay. Oof. We're on to something here. Ooh.
For sure.
Yeah. What do you know? What I wanted to say before, in this case, as you have seen in the first example, I asked Snoop a very general question, how are you? But in the third example, who is your favorite rapper? It managed to respond in the Snoop Dogg style of speech, whereas in the first one, it didn't. Why? Because I've seen that generally when you tell it to act like a character, it is trained on basically text that is labeled as being as Snoop Dogg's text, or I don't know, Dr. Dre's text, or Steve Jobs' text, and it assimilates this text with this character. So when you ask him, how are you, it will say, okay, this is a pretty general question, so there's not much, I cannot assign this reply to somebody specific, although not many people are asked about their favorite rapper or who killed Tupac, although I think many did. So yeah, it assimilates the question as being asked by somebody. Yeah? The sarcastic? Ah, okay. How old is Obama? How old is Obama? He's 44. Or he's high, and he doesn't know. Okay. Any more questions for Snoop? Or we can switch to another character if you want. Okay, let's switch to another one then. Anybody who wants to talk to a celebrity they never had a chance to? Okay. Albert, although I'm not quite sure how Einstein speaks. Okay. What's your question for Albert? What is time? Ooh, what is time? Time is a measure of the movement of matter and energy through the universe. It is a concept that helps us understand change and measure the passage of time. Okay. Can you explain time? Time is a measure of the progression of events. It is often referred to as a fourth dimension along with length, width, and depth.
Nice.
How do you make what? How do you make quantum mozzarella? Is it double Z or double L?
Double L. It's okay.
Okay. One does not simply make quantum mozzarella. It is a complicated process that requires a lot of understanding of the quantum realm.
It's like Sean Bean from Game of Thrones.
Exactly, yeah.
Nice.
Can you explain the theory of relativity in simple terms? When you look at something, you are seeing it in its present form. However, that object also has a past and a future. The theory of relativity is a way of understanding how those three things are connected. That's quite good. Phew. I don't know if, well, there's no one answer to this question. Each person's beliefs and understanding of the concept of God is unique. Okay, but here we can see that it's not the same style as before because the topic of the question is quite different. So it starts to shift from the original style.
Yeah, basically, just wanted to add here, in this example, as you saw, in our initial prompt, we gave almost no context. We just said, you are Snoop Dogg and nothing more. But if you wanted to really simulate that style and keep it, you'll have to just provide a couple of lines of maybe context. Maybe you tell him that you are at a conference or you have an interview with someone. So giving more context will help the model provide you and keep to that style much longer. But what we wanted to showcase here is how out of the box GPT-3 is already ready to simulate, let's say, most famous personalities. If you'll ask something little known, he'll turn to general terms back. So.
Okay, so I think we still have time for something else. Now, I don't know about you, but I always wanted to see how Snoop Dogg and Donald Trump debate about Mexican food. So this is a piece of code that is not in the repo at the moment because it hasn't been that well optimized for a workshop-like environment. But we can definitely play with it. So Let's say Snoop Dogg talks to Donald Trump about, anybody have an idea of a topic? Something, I don't know, anything. Legalizing weed. Perfect. Legalizing weed. Okay. So, if we run this, oh, yeah, sorry. I have to make this a bit bigger first. Let's say like this. Okay, so let's run it again. So Snoop Dogg is going to talk to Donald Trump about legalizing weed. This is, I don't input anything, they're just talking. There's two AIs here that are generating text. I don't input anything. There you go. So this is the debate about weed. Unfortunately, here we haven't quite managed to make it so that it will always generate something like a new sentence, because as you can see here, those are quite similar and they are from different characters. This is because essentially everything that is being said is remembered. So again, the same problem, because we give it this prompt, then it remembers what is in this prompt. So it adapts to this style. And sometimes it just copy and pastes. Yeah, there you go. Let's generate another one though. Let's see if it's that different. Now, yeah, so in this case, the debate is longer, the text that is generated is a bit longer, and because the first two are like this, the rest of the conversation is going to be like this. Well, sort of. There you go. So unfortunately for Snoop, Donald doesn't want to legalize this. By the way, the reason why Donald Trump is acting as president in this conversation is because GPT-3 has been trained up until 2019. So it doesn't know that Elon Musk bought Twitter, for example, or any other major events that have occurred after 2019. So let's switch it up. Let's make, I don't know, any ideas, anyone? Who would you want to see debate about a certain topic? Lady Gaga, okay. And? Who? Dalai Lama, okay. I hope it, and what should they talk about? Okay. This is gonna be interesting. There you go.
Quite friendly.
Yeah. The problem is I don't quite know how Lady Gaga tends to speak. Snoop is very distinguishable, or any other rapper for that matter, but yeah, I guess.
Pretty accurate.
Yeah. Again, it's a longer debate, so. There you go. So what I've done this morning is I've made Kanye West and Kim Kardashian argue. So I've managed to make them argue about money. Sorry? Oh, thank you. Okay, so let's make Kanye West and Kim Kardashian fight about money. This is a very Kanye-like response.
Yes, degree. Strategic move.
I think I'm not really into these things, but I think they were still together when, yeah, GPT has been trained, so they still have this friendly relationship, but I'm not quite sure. So yeah, this is when I run it last time, they managed to actually. Kanye was telling her, "Yeah, I don't care about what you're talking about. I really don't give something about you." And yeah, it was, yeah. So there you go. You can also make, simulate a conversation between two AIs and actually make one AI respond to the other. If anyone has any other ideas, this is our last demo, so we can play around while we still have time. The previous with the bot. Yeah, no, it was not available, but I can, I've just wrote it here. I can push it after this, after this demo. Sorry? Oh, is it too small or? I can push it afterwards and you can play with it. By the way, I've provided you with a key, so if you want to take this code home and play with it, well, it's encoded in hex because, yeah, OpenAI has a very good security system. I'll leave this key functional, I don't know, maybe 2-3 days so you guys can play with it, but afterwards I'm gonna have to delete it because it's within the organization and it's, you know, all this kind of things. But yeah, I'll leave you guys some time to play with this. Yeah.
You mentioned that in the dialogue between celebrities, you mentioned that there are two AIs. How do you do the separation between them? So isn't it just GPT behind both of them? What else is different?
Okay, that's a very good question. Maybe you've seen on YouTube, there are a couple of videos about GPT-3 where they actually, well, let's actually check it out. It's not that long. Where they actually simulate two bots talking to each other, but GPT-3, there you go. No, what was it called? Two AIs talking to each other. Yeah, there you go. So this is the video. I don't know if you have sound or not. I have to wait for the ad. In this case here, what they do is they just prompt, two AIs are talking to each other. They are helpful, friendly, and clever, I think it was. Oh. You cannot hear, I guess. No, if you look into in the description here, they say, I prompt GPT-3 with just 3 lines. And that's it. This is when they don't differentiate. If you do this in the playground, it will generate you a dialogue of about 7 or 8 replies each, or a bigger number depending on, yeah.
But the same engine.
Yeah, the same engine. But what we have done is basically we have created 2 separate sessions, playgrounds for that sake. And in one playground we tell the AI to talk like Lady Gaga, and in the other, when Lady Gaga has asked a question, who was it, the other one? Dalai Lama, yeah. In the other playground, Dalai Lama, we tell it, you talk like Dalai Lama, but you get the question from Lady Gaga from the other playground. So we give the question to the other and the answer to the other one also. And somehow you simulate, you can differentiate between those two characters.
So in theory, you use different parameters for each session,
Yeah,
different models or different fine-tuning.
absolutely, yeah. So you can play with everything here.
We forgot to show you about the fine-tuning capability. So basically, GPT-3 is a pre-trained model, and you query it, and you just change the context, and it changes the answers. But you can adapt it to your specific needs by fine-tuning. What OpenAI means by fine-tuning is you provide a huge data set, the bigger the better, of prompt completion pairs. So you give it how the prompt looks like, how the completion should look like, and you give it as many as possible, and you fine-tune the model will change its weights, and when you will prompt it, even with a zero prompt without context, it should be able to provide the expected answer, and after you fine-tune it, your model will appear here. We have here our fine-tuned models. And you can, after that, you can just use it like any other basic model. You just mention that you don't use a basic one, but you pass in the model name. From our experience, it's quite costly, and you have to have quite a big amount of data to get some expected results. We tried iteratively with 400, 1,000.
We've tried up until, I think the biggest one was around 30,000 rows of data.
In CSV, it was a couple of megabytes, I think, not very large. Of
Yeah.
lines, yeah.
But in our business case, it was very, very specific because we wanted to make it, to transform natural text, natural language to a machine-like command, but a very specific internal thing. But if you, for example, I know there's a tutorial online in which a guy makes GPT-3 generate a Doctor Who synopsis out of normal text. So if you input it like a normal human conversation, from that it will generate a Doctor Who synopsis for an episode. So, and I think he did it with around 700 rows. Yeah, mainly.
So why we are showing all of this, we just wanted to highlight that GPT-3 in fact is a very powerful tool, and if you manage to write a proper prompt, it will switch seamlessly throughout the task. So it can do, we only demonstrated I think 6 or 7 tasks, but it can do I think 20 to 30, very different, like sentiment analysis, text classification, translation. So but the magic is that how simply it will switch to one task to the other by simply reading your prompt. So I want to highlight again that prompt engineering for this kind of tool is very important, and it's not necessary to use GPT-3. There are, I think, dozens already of open source solutions on the market, but they all function in the same, the core is the same. So you have a prompt that you have to engineer properly, then you pass it to the model, and model will output always the best probability out of the context that you give.
So if you want to make this into production, how do you create your testing setup, your validation before going into production with the new prompt?
What we did on one of our use cases, we fine-tuned a model, and then we had a holdout set of prompts and expected completions that we prepared because we knew we want to achieve, and we tested the model with this so that we could validate on production data, let's say. So we, because after fine-tuning, OpenAI provides you with some training metrics, but it's better you use your own. So it's better you always prepare your set of data to test it on real, let's say, real world data, and after that you decide to move or not. But testing, you should be able to manage it yourself, because you should not rely on the split test train split that the model does in fine-tuning. You always have to have a validation set which you pass to the fine-tune model and see the real results that you receive. And we tried with zero shot. It performed like 15% better than the basic model. Few shot it was already much better, and one shot, few shot was much better. That the thing was that zero shot of a fine-tuned model is already enough enough gain over the basic model so that you can decide to take a fine-tuned model or not. Because otherwise you should always use prompt engineering in a basic model to achieve these results. And not always it's a short prompt. So for complicated tasks you will have to use very large prompts.
Lastly, these are the prices for GPT-3. What we have used today is DaVinci, the base model. Here it says they've just been, the cost has just been reduced, I think, 2 months ago or something. So it's $0.02 for 1,000 tokens. And as a general rule of thumb, 1,000 tokens is around 750 words. And as I said, the models go cheaper as they get less accurate, but also they get faster. These are for the base models, and then here you also have for embeddings. You also have fine-tuned models, but they cost a bit more because, I don't know, they just cost a bit more. So yeah. And I think that's it. So if you have any questions, please. If not, thank you.
Thank you.